So welcome everybody, hi again for those who were here yesterday for our presentation. Today again we will show you amazing things. Today we will present you a real use case of how we could introduce a Groovy DSL at our customer. And it's not a small thing, it's a big thing. It's Groovy DSL used by 500,000 people and which concerns more than 2 million scripts. So it's a huge thing, it's not a small thing that we did showing you. Corinne will tell a bit more about this Groovy DSL, and then we will of course have the exciting part of the demo. But first, let us introduce ourselves, ladies first. So this is Corinne. You probably already met her. She's a geek with more than 15 years experience. When she was playing with Spring, I was doing my first Hello World in Java. So she's also a geek husband, and Fabrice over there.
Microphone?
And we got a microphone, yes?
Yeah?
Yeah, okay, thank you, sir. And that's it. And then you will present me? No?
Yeah, right. Sébastien, this is Sébastien. Do I need to introduce Sébastien? That's really Sébastien, yeah. When he was shaved and short hair. So Sébastien is my geek friend. We work together for the Three Musketeers. We organize RivieraGUG in France. We do a lot of stuff together. We used to work together. Sébastien left Amadeus, where we work. Is now working for Red Hat, Shibos, as you may already know. And that's it, Sébastien.
Okay, so Corinne, can you tell us a bit more about well, the use case, the Groovy DSL, well, the DSL, what was the problem or the problem?
Yeah, so Sébastien, to give you a bit of background, we're working at Amadeus. Amadeus, I don't know if you heard about it, it's a company that is a GDS and doing a lot of stuff around travel industry. It's a Spanish company, yeah, actually you're right, yeah. It's based in Madrid, actually. Yeah. Madrid. So I'm in the business team. I'm working for a team that's developing a web application which is called Amadeus Selling Platform Connect. This application is targeted for travel agent, and we target two kinds of travel agents actually. Novice travel agent, so it's could be a travel agent working from home without expertise in the area, or expert travel agent. So the information is displayed in two different forms. When you want to do a flight booking, either you do it through the UI, opening what we call a booking file, and then you can add passenger. You see here, it's a passenger section. You can do your availability and all the stuff you need to book a flight. And that's for novice. Same thing for expert. You can switch to the cryptic mode, and you can do all that in command line. This is called the cryptic language. It's actually by itself a DSL, which was written I think like 20 years ago, which used to be actually taught in specialized travel agent school. I think it's not anymore actually, so we're moving forward more
user-centric.
Yeah, user-centric view. So, two different ways of accessing the information. But do you know, Sébastien, what is the most important thing for a travel agent when he's got a client on the phone?
To go fast. Because,
exactly.
Client is also demanding, especially if it's Mr. Rich.
Especially if it's Mr. Rich. Yeah, exactly. We want the purpose of a travel agent is to book a flight as fast as possible. So efficiency is key, and that's where our project comes into the scene. Productivity Suite is actually a way of speeding the productivity of the travel agent. In the previous version of Cell Connect, like 30 years ago, 20 years ago, I would say, there was a product that we call Selling Classic, as opposed to the new Selling Connect. And there was already the idea of being able to do macro on the cryptic command. For example, a travel agent book a flight to go to Madrid on a certain type, and he has to do 20 bookings for 20 different persons. He wants to be able to just call a macro, and that will do the job for him. So this is a smart key, the previous version of the macro language to do it. As you can notice, it's got a lot of angle bracket, and to the discharge of the previous development team, actually, this language was written, I think, in the 90s in the glory period of XML, so which can explain the XML look.
XML, yeah, because actually it's more an XML bastard.
Yeah, it's not really XML because you don't have closing bracket and all that, but you can. I remember when we worked together on that. Yeah. We always get lost on the angle bracket. Is it closing or opening? Because you, yeah, remember that old memories. So, sorry, yeah, to go back to finish the story. Actually, the travel agents were very happy with the macro, but as it gets more complicated, you add more feature in it, they get lost, and eventually they say, oh, you need to be a travel agent geek to be able to write those kind of things. So we want something simple. So that was the requirement. We want something simple. So define simple now. So we came up with a DSL. And we wrote the DSL in two different flavors. The same idea that we have the booking file and the cryptic mode. Here we've got our DSL that you can define graphically. And if you click to the switch advanced, you go to the advanced mode. In the simple mode, what we call the simple mode, you cannot do all the action possible on this DSL. But here, for example, I highlight the last name and I can ask a question. So it's a way of doing a macro on the cryptic command itself. If you switch to cryptic mode, then behind the scene, it's a Groovy DSL, and all you're seeing here is a Groovy DSL. To express, I want to ask a question, I want to assign it to a variable, and then I want to send it to cryptic or do different things. We've got several different verbs here. I didn't show all the implemented verbs. So that's...
But the most important thing is here, it's plain old English. So someone who don't know any programming language can just type English, ask question, assign to, and that was major enhancement of the previous bastard XML.
That made it simple. Yeah, you can read it.
Keep it simple. But Corinne, we are talking about DSLs, but could you explain to everybody and to me also what exactly a DSL is?
Yeah, let's give a definition. So DSL doesn't stand for damn small Linux. DSL stands for domain specific language. So from the definition from Martin Feuerler, we can extract actually the definition, which is it's a computer language of limited expressiveness focused on a particular domain. From that definition, there is three key things to extract. First, it's a computer language. So it's executable code. So at the end of the day, it's a code that should be executed on a computer. Second, it's a language. So if you put together the semantic and the syntax, you could get a feeling of fluency. So for example, if we take the example of the SQL statement, you can read a SQL statement and get the fluency here. If you can get the joke, you get the fluency. Last but not least, it should be focused on a particular domain. It's domain specific. So for example, if we take the RivieraGUG example, what we need to do all the movement on the RivieraGUG, it's you need to define the 6 faces, and you need to define if you move it clockwise or counterclockwise. And that's all you need to express the movement on RivieraGUG. So it's limited. I don't need I don't need a loop. I don't need many things. Okay, we've got a clear definition, but you know what? Actually, boundaries are blurries. It's actually not difference is tiny because between a tiny programming language, a scripting language. Here I chose our favorite one. It's Groovy. And the Fluent API pattern, the command chaining pattern. Here, the holy grail is always to write code that you could just read. And that's what you're trying to achieve when you're writing a DSL. You want to make it crystal clear.
Crystal clear, yes. One last difference?
Very often you can separate DSL in two categories. Either external DSL, it's a DSL that you define from scratch. You define your syntax, you define your grammar, you define your parser. You can either use a parser framework like Antelia, JavaCC, or you write your own customized parser, whatever. But you do everything from scratch, it's executable. As opposed to internal DSL, also called embedded DSL, and actually it's this kind of DSL we're going to see in more details. It's actually, like here I took the example of Spock. It's a language, a subset of a language that can run on a host language, and here the host language will be Groovy. So, Sébastien, if you were to build an embedded DSL, which language would you choose?
Not really sure about the answer. Groovy, of course. And why?
Why Groovy? Yeah.
Why Groovy? Because Groovy works, of course. Now, to be serious, Groovy. Well, first of all, it's a scripting language. So to write a DSL scripting language is well, a really good start. And it's a scripting language which respects the scripting API defined by the JTW specification, so you can easily plug it into an existing Java architecture. And then Groove itself, well, I don't have to learn it to you here, but you all know how Groovy is expressive and easy with all this syntax sugar. You don't need semicolons, manipulating a list is so easy. So it's all really, really clear. And then you can play with the language. You can strew the language. You can, at runtime, add methods with metadata programming. And you can even go further at compilation time. You can do whatever you want with AST transformation, as Andres showed us yesterday with the AST. So you can really do whatever you want with the code, and that's exactly what we need for a DSL. So Groovy was the best choice in our situation.
I'm convinced too.
Okay. But I think want to show. Oh, sorry, someone is calling me again. I don't believe this during my presentation. Hey, hey, Mr. Rich again. How are you? Making a lot of money with the Foursquare application? Yes. Okay. Okay, but you got a new idea. You want to build a survey software where people who don't know any programming language could submit a new survey. Okay, and you have chosen us, of course. Yes. Yeah. Okay, let me call you back in a few minutes and see what we can do. Okay, it's Mr. Rich.
Mr. Rich again? Again,
but he's demanding, but he's paying well, and well.
Exactly.
I'm sorry, he's always calling during presentation. So, Corinne, you heard it. Mr. Rich wants a survey software, and he wants that people just can use almost plain old language, English language, to provide questions, answers, and all this stuff. So let's go behind the computer.
I think it's an interesting use case, huh?
Yes. But first we need a scripting environment. That's what we got here with just a shell. But for a survey, what do we need to do with the survey?
I think for a survey you need to ask a question.
Ask a question, yeah.
Ask a question. And,
so let's define a closure called ask. Look how I can type fast.
Wow.
Well, impressive.
I'm impressed.
I'm
amazing fast typer. Huh?
So really simple. I just defined a closure called ask, which takes the question as parameter, and for now we just print it out, and then we call the closure with our question.
Yeah, that's exactly what needed. Huh?
Let's give it a try. Hey, it's working. And just to show, people will say, yeah, that is a static slide.
No, that's not just slides.
No.
I've got a Groovy console.
Question at Greach. So you see what we got here is a Groovy web console inside an HTML5 presentation. Really, really cool. So,
going back to the script,
no. You think so? No, go to the second point.
Yeah, sorry.
So we got our first question. Are you okay with that, Corinne?
But I think it's nice, but you know what, Sébastien, we're not going for each script. We're going to have to define or ask method.
Yes.
I don't think.
They just we send it as a text file and do copy paste of the definition before writing a new script.
Copy paste, is that a best practice?
Okay, let me think. Let me think a bit. Let's think OO for a moment.
Yeah.
What is the first principle of OO? It's something like class inheritance.
Okay, you can use inheritance for the scripting. That's what you're suggesting.
Yeah, and I know that with Groovy scripts you can define a base class. And in this base class we could put all our stuff, and our script will just inherit this base.
Okay,
class.
so we won't have to define ask every time, but just write the call of the ask statement.
So
okay.
let's start by defining a base script. As you can see here, the survey script, where we put our ask closure. So we don't need the ask anymore in our script, so we can remove it. And then what we need to do.
How does the Groovy shell know that it has to look at this service script instead of looking at the script one, which is a default one? Huh?
Now we have to tell the Groovy shell that he has to use the base script we just defined. So, you know what? We can use a class called compiler configuration.
Okay.
So let's write one. I'm typing very fast again.
Wow.
Okay. And here for this compiler configuration, we got an attribute called script base class, and we passed our survey script here. And then we need to tell the Groovy shell he has to use this compiler configuration. And how we do that? Well, it's really simple. The constructor of Groovy shell can take some parameters. We have to pass a class loader, a binding. For now it's just an empty binding, and our compiler config. So
that looks cool. You think it's going to work?
Yeah, I think so.
Let's give it a try.
Hey, it's still working. And now we got a really nice script, just ask, and all the rest is encapsulated in our base script.
Okay, so let's call Mr. Rich. I'm thinking.
Mr. Rich. Where's my phone? Oh,
yeah, over there.
Yeah. Hey, Mr. Rich. Yes. Yeah, we got the first version working. Yeah, we're incredibly fast. Yeah. But you want to store the answers of our questions. Seems.
Yeah. Maybe he wants to ask several questions.
He wants to ask several questions and to. Okay. Let me call you again in 3 minutes or 4 minutes. Okay. Bye. Okay. We need to go a step further now. For sure, we want to store the answer of the question into a variable, and we want to make that really expressive and really.
Yes, so we need to define. We need to revisit our DSL and define a new
keyword, a new sentence. A new syntax.
So we
like
do
ask, what is your name?
Into name.
Answer name, for example, or name.
Yeah.
So
that sounds great to me. Let's give it a try. We try like this.
Yeah, but what could we use for that?
Yeah, basically I think we need to use one of the technique which is called command chaining.
Command chaining. Can you explain us a bit what is command chaining?
Yeah, I give you an explanation. So command chaining is a common technique in object-oriented. Very well known if you use jQuery, for example. You return yourself, you return this, and then you can chain the different method call so that in the same line you've got like a sentence. That's a Fluent API pattern actually.
Okay.
Okay.
And we can do that with Groovy?
Of course, and it's even better because with Groovy you can skip the punctuation and it look really like a natural language because you can remove all the bracket and all parentheses of the call.
Okay, so
let's give it a try.
Let's give it a try. Okay. What do I need first? I need to define a new keyword.
Yeah, let's focus on the script. What do we want?
What is the final result we want? We want that we can assign an answer into a variable. In this case, what is your name? And store it into name. And we can have, of course, several questions. So first thing we see here is into, which is new. So let's define that.
Yeah, let's define a new method. First we return this.
First we return this, of course, as ask.
To chain.
To be able to do the method chaining, so ask return this. And after that, we define
the into method.
The into method. The into method gets the name of the variable where we want to store the answer. So let's create a map which will hold all of our answers. Just an empty map. And then we actually store the question and then we store the answer. And then
I think that should be it, no?
That should be it?
Yeah, I think, yeah, we shared it and we could just, let's run it.
Let's run it. Hey!
Oh.
What's happening? An error. Unexpected.
Sébastien, you screwed up that.
I screwed up the whole thing. Oh.
What is it, this?
Hope Mr. Rich will not call it me right now. Okay, but let's take a look at the error. It say no such property name.
Let's go back to the script. I think we must have missed something. We must have missed name. Yeah, it's a variable.
It's a variable and it's not defined, so the error is correct. Property does not exist, name.
Yeah,
but
makes sense.
I don't want people to define empty variables, def name, def.
I know it wouldn't make sense in our DSL.
But there's something in Groovy. If a property is not found, there's a closure called by default. If you
property missing or
property missing. If you define this method, it will be called in case the property not found. So I think it's a perfect fit to use this now. Okay?
Exactly.
Okay.
Let's give it a
try. Let's define it. Very simple. Property missing, as you can see here, it takes as parameter the missing property as a string, and we just return it as a string here. So that should be okay. And we just define a display to have a result for all of us to prove it's working. So I think we can give it a new try.
Yeah. You think it's going to work?
Yes.
Sure?
Sure.
Wow.
Look, it works.
Yeah. So we got our first question and our second question with the answer. So variable name.
People can now just choose, create new variables even if they're not defined, and we take care of this.
Well, I think Mr. Rich will be really happy. It's exactly what he wants.
It's exactly what he wanted. So,
shall we call him?
Shall we call him? Okay. Mr. Rich, yes, we got it. Yes, you can try it. Ask question and then you do into and the name of. Oh, you don't like this. You don't understand into. Huh? That's strange. You want assign to. Ask question and assign to. Okay, let me see what we can do.
Very
rich, very rich.
He's not happy with the sentence.
No, you don't want into. You want more expressive assign to.
It's two words there.
It's two words.
Wow, so it's
Maybe
changing our
use
design.
an underscore? No? No.
I don't think he will like it.
You don't like it.
So back to the command chaining.
Back to command chaining.
So remember, we had ask question into. If I put the parentheses around, it's more. We've got the chaining of two method call, simple. But now, as Mr. Rich wants more, we have an odd number, so we're going to go for differently. We have a first method, ask question, then we chain with a second method, assign to, with a to that it's not useful for anything actually.
No.
It's called a silent word. And then this assign to will return a map, and then we take an element of the map with a dot. And with Groovy, because you can skip all the punctuation, you can remove the parentheses and the dot, you could have it like plain old English without any parentheses around, and it looks like magic, like plain old English. Let's see it in action.
Okay. First of all, let's see the result we want. So we will replace the into with assigned to. Okay, so what we need now is we need to change the into assign. Right?
Yes, right. That's exactly what we need.
Assign to, and to takes a parameter. Then we implement the assign closure, and here we are using a really useful method offered by Groovy when playing with maps. It's the with default closure, which will be called if the key is not found. So in our case, it's what we need. And I'm number 4?
Yeah, number 4, yeah.
Number 4. Here we implement this. Corinne, can you just explain me the what we put in the with default
we just basically we want to store the name of the variable, and we store it. If it's not defined, we store it in the map.
Okay.
And then we can reuse it when we do the dot variable name.
Okay, so
if
I go back to the script, if I execute this now with assign to, we should have the same result as just before.
Yes, exactly. Okay. Let's see.
Hey, it's still working. We're so good.
We're almost done, but you know what thing? Because it's a survey, it needs user interaction.
That seems, yeah, a good thing to think about. Users need to answer the questions, so we need some interaction. Okay, let's just take a quick sequence diagram. Our DSL is running on a backend server. So the client connects a web client. He requests a survey. We return the first question. The client answers the first question. He processes the answer. He returns the second question, and so on and so on.
Yeah.
So we need some kind of structured things to pass the information
back and forth between the different script calls. So what can we do about this? Maybe we can talk in details about the binding we saw earlier. Remember?
Oh, this empty binding.
What is it for, the binding?
Okay. Let's just show how binding works. We got here our empty binding. Let's set a variable inside our binding, which we call the which meals, and that corresponds to a question. And let's just change our script to replace to add a new question which use a variable defined in the binding. And
if we run that, I think we should have 3 questions.
Yeah, an important thing is that this variable is defined outside the script. So this means if it's defined outside the script, we can handle that. When we go back to the server, we can inject that again. And
exactly,
no?
It will be our context.
Just to be sure, let's see if it works. Hey, still working. It has been replaced, so we can deal with that. So that's a good part. But the script right now, if we execute that the first time, well, all the ask will be executed in once, which is a bit stupid, no?
Oh yeah, you're right.
Because it has to ask first question, go back to the
and then go back
client,
to the script.
The client answers, go back, and the script has to be executed again, but this time we want the second question.
Oh, so we want to keep the line number so that when we come back, we are the second question, not asking again the first question.
So we have to transform our script to get some structure control.
I think here we need to delve into the hardcore AST transform here.
No. Okay, can you explain us a bit what we are going to do?
Well, I'm going to explain you the technique we used actually to do our AST transform. Basically, we've got a script here. Ask what is your name with 2 statements. We want to be able to ask the first question and then go back and ask the second question. So we need to know we're on the second question. So what we're going to do is we are going to transform each statement, wrap it in a method. Do step 1, and here I put my first statement, and then a second method, do step 2 with a counter incremented, which corresponds to the line where I am in the script. And then I will replace, you know, each script got a run method, as we saw earlier. I will replace a run method. Take all the statement, replace all the run method with a dispatch method that will dispatch to the proper method. So the first time the dispatch method will do a do step 1, and the second time the dispatch method will do a do step 2. So it will be executed only once. Okay, so
show me some code.
Let's see the code for that. Here it is. So to simulate the fact that we go back and forth, we're calling the script twice here. Notice that we use the get shell method, which is defined here. Each time we define a new shell. It's a brand new shell, but we put the binding, which is defined only once. So the data go back and forth, but it's a brand new shell. So that's how we simulate the fact that we go.
Here we simulate that we go to the front-end client and we come back and we execute the script again.
So back to our DSL, you notice that we've got the ask method. We put it a bit more compact. We do a counter increment for each ask statement. Every time we go to ask, we increment the statement because all our statement in our DSL are ask for now. So we increment, and then we've got a dispatch method over there, and what it's doing here is invoking the method. In the invoke method, that's why we do our do step 1, 2, etc. with the counter. So now, if we...
So it uses the counter from the binding to see, hey, now it's question 2, I have to execute the method called do step 2.
Exactly, Sébastien. In the binding, we pass back and forth the context where we are.
Okay.
So
let's see some AST now.
Let's see some AST transform. So in the call method here is what we're doing here. We're looking for the run method in our script because we're only interested in the run method. In the run method, we're collecting all the statement, all the ask statement. I save them in method course list, and then what I do I'm going to replace the content of the run method with a dispatch method. I kept the method call here that I'm going to wrap in the add statement method defined below. Here is the manipulation I'm doing on the code to wrap them in a do step 1. I've wrapped them for each here for each of my method call. I've wrapped them in the do step 1, and that's it. Nothing more complicated than that. So,
so just to summarize, as you know, when we compile a script, all the content is put in the run method. So we take all the content of the run method, we throw it away in a list, and we replace that just with a dispatch call. And then for each statement, we create a new method with AST, which wraps our asks.
Exactly.
Okay.
We give it a try?
Let's give it a try.
Okay. And here it is.
And here it is. So the script was executed twice.
The script was executed twice, but you notice that we've been asking the first question only once, and we've been asking the second question only once. So it's exactly what we wanted to do. I'm sure you will be very happy, Mr. Rich.
Yeah. Let's go on again. Mr. Rich, yes. Okay, we get it all working with the assign to, where we are dealing with user interactivity and oh, what you want a when statement to do some conditions. Well, just do a pull request first. Now I'm joking. Okay, a when statement. Let me see if we can do that. Okay, Corinne, just one last thing. You want to be able to do some condition, like when age, or ask for age. If age is less than 18, don't ask the next question about the strippers.
I think it's not that complicated. Basically, what we need is to add a new statement in our DSL, a when statement, and we also need to move a bit the AST transform. So let's see the diagram. Let's see what we need to do. So here is the use case. I want to have when, and I'm sure Mr. Rich, as is very demanding, is the next requirement will be to have imbricated when. Okay, that I'm sure can come. So we do a when like that with a block, and you could do as many when as you want. So I want to transform that. Same thing, I'm going to use the same technique as before. I'm going to wrap my statement, but here I need to flatten the when statement. That's what we're doing here. For example, if you see the first statement here, I'm doing a condition check here and then the actual content of the ask. And here I'm going to flatten this when with an A statement, and all that will be done with an AST transform actually. And then same logic here when we flush all the content of a run method and we do a dispatch with the counter information. So if we look at the code, so very similar. Here we've got our script and we emulate with calling it twice. The thing that has changed here, one of the problems actually that come with a when is that when you're doing a when statement server-side, you actually want to carry on server-side. It's not prompting for the user. So we need to evaluate the next statement still on the server-side. So that's the purpose of this new boolean here, saying that when I am in an ask statement, I don't want to carry on server-side. I want to go back to the client.
But if I have a when, I want to stay in the script execution.
Yeah, I want to carry on. Okay. So here, that's very simple DSL. Here, the when statement is just taking a Boolean expression. It's just a simple method taking a Boolean expression and a closure actually. And with the syntax of Groovy, you could remove the parentheses and add just a block statement for the closure. So here, if it's true, I execute the closure. If it's false, I just increment it because I go to the next statement and I just don't do anything. So if we go to same thing here, the dispatch method, so just the difference between the previous one is here I've got this recursive core because I want to keep going, except if I have an ask, then I want to exit. Keep going, if I have imbricated when, I'm still evaluating server side. Okay. Then in the AST, actually, same thing than earlier. In the run method, you collect all the methods and then you flush the run content, you replace with the dispatch, same as earlier. It's just a bit more work here in the statement. We're not just basically taking the statement like that. We're doing a bit of processing. If it's a when, I need to, and especially if it's a when imbricated, I'm doing here a recursive core until I go to an ask statement. In case I'm in the ask statement, I'm here. I'm going to move. So here we just played between when and ask to do the right transformation. We're flattening the when structure, and basically you can see here I'm replacing the when with a. So it's a remember the syntax become, and I had all my. I think that's it. That's all we have to do. All we have to do, and we've got the when statement, and then you can add as many new languages as you want. Okay. Okay. Let's go back to the script just to see if it works. So let's execute it with a false statement. So here I want only one question. No? Okay. And where have you put it on false? Sorry. Here. Here false. Okay. So if false, imagine it's come from binding.
we want to ask the second question though.
Yeah, okay, so if it's false, only one question to be executed here, and that's exactly what we have. I'll show you with a true statement to see how it goes. And here we've got our second form.
Go to the so we got the when working.
Everything ready to go for a real survey.
Okay.
Shall we show an example?
We show an example because let's put it not in a Groovy shell anymore, but really on the server.
Okay.
With running with Grails, because Grails is cool.
Show us the example.
Yeah. Hey, there it is. That was really quick. So we got exactly the same as we show you, just the whole Groovy shell script compiler configuration is wrapped on the server side. And that should work if we execute it. Let's try it. So, what's your name? Seb.
You click on next.
Next question, Seb. Why did you come to Greach? Because. Very good answer. Is this Groovy great or awesome? Awesome.
Are you not saying yes to the script?
Oh.
Look at the script definition.
Oh, look at the script definition. Sorry. Sorry. Yes. Yes, of course. The best workshop ever. Are you going to the workshop? Yeah. With the Three Musketeers? Yes. Would you come back? Yes. Yes, we can. And look, here we got all our answers, our survey. So has been processed at the back end. And well, almost everyone can now write a survey very easily with this DSL. And Mr. Rich will be very happy, and we will be a bit more richer.
Hopefully.
Hopefully. Okay, so I will call him later, because now it's time for question and then it's time for lunch. Okay, so important thing, yeah. The presentation you just saw here, you can just access it here on dslpress.cloudfoundry.com. You will have exactly the same presentation with all the Groovy consoles, so you can play if you want with it. It's also on GitHub, so if you want to hack it or to provide some pull requests, don't hesitate.
And also because it's Twitter Bootstrap, it's also very practical to use it on a tablet.
On a tablet,
you can even play on a tablet with it.
You can do Groovy on
you do your own DSL with it.
You can do Groovy on your iPad, so that's pretty cool. Special thanks to Fabrice, which has spent a lot of hours helping us in this presentation.
Fabrice, my geek husband, actually.
Yeah. And now time for a question, if any questions. No?
I think everybody is hungry.
Everybody's hungry. Okay, so thank you very much.